All right, worksheet 6. I'm actually going to go ahead and work all of this one. Don't be afraid to go ahead and just copy is okay and listen, but if you feeling adventurous, go ahead and stop, especially on the second part, and see if you can figure out first, and then if you can't, then listen. But either way, it's fine. So here we go. So Candace has 60 feet of fencing that she will use to make a rectangular pen for her dog. So the graph shows the area of the pen as a function of the width of the pen. So we have the width of the pen, and we have the area. So the area is a function of the width. The situation can be represented by the function y equals 30x minus x squared, where x is the width in feet and y is the area in square feet. Complete the table and show the first and second differences. Okay, so we could complete this table just from looking here. So 0, 0, 5, and we can go up here and see where that is. I actually went ahead and typed this into Y1 in my calculator and looked at the table just to make it a little bit simpler. So at 5 is at 125, 10 is at 200, 15 is at 225, 20 is at 200, 25 is at 125, and 30 is back at 0. Okay, so we can tell here from the table what the vertex is. The vertex is this point here, from the graph. And from the table we can also see where it is, where it was the highest, which was at 15,225. Also the zeros are here and at 30. So that's saying that if it was 30 feet long, then it wouldn't have any width. Or it says 30 feet wide, it won't have any length, and so it will have 0 area. And all of these are different points in between. So what's the largest area possible? We just talked about that. So it is 225. And we can put a label on it, square feet. Circle the point on the graph that shows the largest possible area. So we talked about that too. Do you remember where it was? Largest possible area is here. And what names can we give this? Well, we can call it the vertex. We can call it the maximum. Or we could call it the point 15,225. All right, so for our symmetric points, remember our symmetric points are 2 points that are the same distance from the vertex. So if the vertex is 15,225, this is 5 less, and this is 5 more, and look, they have the same y value. The same thing here, 10 and 20 have the same y value. It's going to be true anywhere we go down here. At this distance, there's going to be one straight across from it. It's going to be the same distance from the vertex, or from the line of symmetry, and it's going to have the same y value. So one set of symmetric points might be 10, 200, and 20, 200. Again, the symmetric points are going to have the same y value. So what does the point 5, 125 mean for this situation? So x is the width. So that means it has a width of 5. And if it has a width of 5, it has an area of 125. So we have a width of 5 and an area of 125. I actually left something out over here. Realizing I left a part of the directions out here. It says complete the table and show the first and second differences. So let's go back and do that as well. So our first differences are up by 125, up by 75, up by 25, down by 25, down by 75, and down by 125. You see those are all different, so it's not a line. And if we do our second differences, it's down by 50, down by 50, down by 50, down by 50, and down by 50. So since the second differences are all the same, then it is a quadratic or a parabola. We also know that it's a quadratic by the fact that there is an x squared there. All right, I'm going to go down to the other example, but again, like I said, don't be afraid to pause the video and try it on your own. But if you don't feel like it, that's okay. It would just be, it's up to you. If you feel like challenging yourself, go ahead and give it a try first before you watch the rest of the video. So here we go. Bart kicked a football. The height of the football is given by the function y equals 80t, t standing for time, minus 16t squared, where t is the time since the ball was kicked. The graph of this quadratic function is shown below. So don't get thrown off because this is a t instead of an x. It's the same thing. So we have time and the height. So height is a function of the time. So what is the approximate height of the ball when it is at its highest point? All right, so it's up right here at its highest point. We also call this the what? We call it the vertex. So the vertex is going to be at 2.5 seconds, and it got up to 100 feet high. So it was 100 feet high at its highest point. Now, how long was the ball in the air? So it started here at 0, and then it ended up at 0 here. How many seconds is that? So that is 5 seconds. And approximately, when was the ball 40 feet in the air? So if we come up here to 40, do you see that it's two different times it was 40? It was 40 feet in the air on the way up, and it was 40 feet in the air on the way down. So it was at 40 at about 0.5 seconds. And at 4.5 seconds. And again, these 2 points would be called what? Symmetric pairs. Because they have the same y value. And if you'll notice, they're the same distance from this line of symmetry. All right, that's it.